In our previous lesson, we came up with this result that sine of x will always be less than x, which is less than tan x for small values of x. Now, if you divide each of those by sine x, what we get is that x on sine x is greater than 1, but it's less than 1 on cos x. Now, look, we did part of this last lesson. With this result here, as x approaches 0, we know that cos of 0 is 1. That cos of 0 approaches 1. We know that cos of 0 is 1. So as x approaches 0, but I've got a problem with this one because you're not allowed to do 1. Actually, you are. 1 over 1 is 1. So as x approaches 0, cos x approaches 1. Anyway, the limits that you need to learn are just here. The limit as x approaches 0 of x on sine x is 1, but you can also flip that. The limit as x approaches 0 of sine x on x is 1, and the other one is for tan. The limit as x approaches 0 of tan x on x is also 1. So you need to learn those. Now, just some examples here. The limit as x approaches 0 of 2x over sine 5x. So you say to yourself, I don't want it looking like that. I want 5x over sine x. So you write what you want. So with this type, we say we really wish, whatever sign it is, sine of whatever, it needs to have the same thing on top there. So it's 5x on sine x. So you say to yourself, I don't want the 5x there. So what you can do, you actually don't need the x's here, but you can say, I don't want the 5 there. So if you don't want the 5 there, you put a 5 down here to balance it out. Does that make sense? But then you do need the 2. So some people could write it like this. I'm going to cancel out that 5x by putting a 5x down there, and I'll add the 2x, which is what I want. But 2x on 5x is actually just 2 on 5. So therefore, it's the limit as x approaches 0 of that times 2/5, which is just, remember this bit is 1 times 2/5, so the answer there is 2/5. So girls, you don't have to put 2x on x. You can actually just go straight to and say, I don't want that 5 there, so I'll balance it out with the 5 down here, but I'll add the 2 to the top. So I do have 2x and these 5's cancel. So I actually do have what the question is. Okay, with the next one, if you ask this sort of limit, and this would probably not be in a 2-unit paper, you might be asked something like this in extension paper. You say to yourself, I don't know how to do that, but what I do know how to do is sine 3x on 3x. Does that make sense? So if you're just introducing a 3x down here, you're going to have to introduce one up there so that they actually cancel. Then with the tan half x, you could do half x over tan half x, but you can't just go and introduce that. So you'll cancel that out by writing a half x down here on the denominator as well. So they will cancel. So therefore, this question becomes the limit as x approaches 0 of sine x on 3x, and the times this limit as well of half x on tan x, and then these two can be grouped together. So you've got 3x and half x over here. So we're multiplying this one and that one together and forming this. But remember, the x's cancel here, and 3 divided by a half is 6. So you just get this 6 here. So the limits of each of these are 1. Got it? And then you've got your 6 there. So times 6. Now, let's just practice these. How are we going to do these? The limit as x approaches 0 of sine 3x over 2x, wouldn't that just be the limit as x approaches 0? What would you like it to be? Sine 3x over 3x times, but what do you need down the bottom really? So you can put the whole x things in there if you want. You need the 2x down the bottom, or you can just put a 2 if you want. And what would I put at the top? 3. If you want, you can write 3x, 2x, and then cancel the x's off. But it'll be the same as that. Do you get that? So what's your answer? Isn't it just 1 times? See, you need it to look like that. So this 3, I don't want it there, so I put a 3. If there's a 3 on the denominator, I balance out with a 3 on the numerator, and I put what I do want there. Okay, so therefore your answer is just going to be 1 times 3 over 2, which is 3 over 2. What do I do here, girls? It's a common denominator. Before you add fractions with common denominators, it's like I'm doing 1/7 plus 3/7. I separate them. Both of these are over 4x. So I write it as two separate things. The limit as x approaches 0 of sine 2x over 4x plus the limit as x approaches 0 of tan x over 4x. You then do each of those separately. Do you understand what you need to do now? Okay, so what are you going to get? The limit as x approaches 0 of sine 2x over, you want it to be 2x, times, what are you going to put? Cancel out that 2 with a 2, but what are you going to put down here? You want a 4. You can just go times a half, you know, but that's okay. If we just stick with this method, I could have just gone times 1 over 2. But I like to do, if you don't have what you want there, cancel it out up here. Do you know what I mean? And put what you do want. Plus the limit as x approaches 0, what are we going to do here? Tan x over x. You can go, if you want, what are you going to do? Well, I just need a 4 down the bottom. Yes, yeah, okay. Now that's really, what is that just? A half. So therefore, it's a half times 1, do you see that? Plus, what's this one? Plus a quarter times 1, which is 3/4. So it's this limit and that one. With this one, question 3, the limit as x approaches 0 of sine of 2x over tan x. That's going to be the limit as x approaches 0 of sine of 2x over 2x, and cancel out that 2x with another 2x up there on the numerator, times x over tan of x times, remember this is the limit as x approaches 0 of that. What am I going to do? I just introduced this 2x up here. What do I do with it now? Times 1 on x. So if I do just in my mind, they would cancel, but you actually don't cancel it. Now that equals the limit as x approaches 0. Now what's sine of 2x over 2x? I'm just going to put my 2x there for now. 1 times 2x times, what's this limit equal to? X on tan x. Times 1 on x. Now, what does that equal? Wait. Times, because why is the other one a plus? Because you've got two separate fractions. Okay? This one is a multiply. So now what do I do? So it's the limit as x approaches 0. What's 2x over x? Of 2. Well, there is no x term in there. What do you think the answer is just going to be? 2. No, it's 2. All right? If, let's say you got this exam question, you had no idea what to do. You forgot how to do this. You know what you can do? Go into radians mode. And this is also to check your answer. But you can go, x is 0.1 radian. And now you could go sine of 2 times 0.1. Isn't that sine of 0.2 over tan of 0.1? So you can check your answer by putting x equals 0.1 radian. Make sure you're in radians mode. Therefore, you'd go sine of 2 times 0.1 is 0.2 over tan of 0.1. And you should get 1.999, whatever. So 1.980, obviously this is heading towards 2. Okay? So if you find that that value that you chose isn't small enough, do 0.05. So if you want, now do sine of 0.1 over tan of 0.05. So I'm doing x is 0.05 radians, even smaller. What do you get? You should get even closer to 2. Do you see what I'm saying? This one, you get 1.995, ... sorry, I should put the approximately there, which is approximately equal to 2. Remember, it's the limit as x approaches 0. If you do x equals 0, what are you going to get? No, you're not. undefined. You are not allowed to divide by tan 0 because tan 0 is 0. So this is why these are limit questions and not calculate the value when x is 0. It's the limit as x approaches 0, because if you put tan of 0, which is 0, and you divide anything by 0, it's undefined. So this will approach to but never equal to. All right? Get the idea? Limit as x approaches 0. What do I do with this? I've got a fraction common denominator. You separate it. That is x over 3 minus sine of 2x over x over 3. Now I'd really like, what's x divided by x over 3? X times what? X, which is cancels. Minus sine of 2x, how would you like that to look? Over 2x times, put the 2x or just the 2 there, I'll put the 2x, over x on 3. Now, so girls, that's fine. I've just put that 2x there. I can't just put that 2x there. So I'm going to balance it out with another 2x. See, this one's easier just than going 2 over a third. It would be a bit hard. So that and that cancel. That's what I should have. Let's just start cancelling out some of these x's. Limit as x approaches 0 of what? 3 minus sine of 2x over 2x times, what's 2x divided by x over 3? It's 2x times 3 over x. You know what? Instead of guessing and getting it wrong, write the extra line. Dividing by a fraction is the same as timesing by the reciprocal. I don't want to see 2/3 there. And you could very easily make that mistake instead of writing 6 if you don't write out what you're doing. So therefore, it's the limit as x approaches 0 of 3 minus, now I can see exactly what it is. 3 minus 1 times 6. What's the answer? -3. So it's just -3. There is no x there anymore. Like, yeah, there is. It's that bit. But these just form 6. Sine x, limit as x approaches 0 of sine of 2x on 2x is 1.